All right, here we are. Again, we found this contingency table. Just to reiterate, you put your category names in here, then you put your numbers in these 3 groups or 4 groups or however many you've got. We hit stat. Let me think. Tables, contingency with summary. You said all the columns that had the numbers in them, and then you pick your row variables to be your category names, like average, below average, and so on. And you said calculate, and oops, oh wait, go on, let me edit that. Don't say calculate, say next. Click expected counts, there you go, and the chi-square, calculate. You don't really need to hit the expected counts because we already found them, but you can check yourself. Let me copy and paste it in. I'll paste it down here. Boom. And you can see 35.77, 35.77, 79.68. 79.68. So it gives you the top number is the real number you had, 21. The bottom number is the expected count. And when you look at it in the output here, it kind of makes it a little bit more obvious, right? And it tells you the cell format right there. See it? Count, expected count. So there you go. So that's another way you could have found those expected counts right here, rather than using Excel, which was actually kind of laborious, to be honest. And StatCrunch was easy as pie. And then you can see your chi-square statistic and your p-value right down there. They're going to be handy. And so that's how, when I did these, that's where all this came from. See? It's the exact same thing that we're looking at in Excel and StatCrunch. That's where I got this outcome from. And then I also did it with Minitab for a slightly different look. There it is. All right, so what were the null and alternative hypotheses to these? Well, the null hypothesis is that happiness and income are independent. Money can't buy you love, right? And then the alternative is that happiness and income are not independent, right? That's just a lie, that it actually, when you have more money, you are happier, or something like that. All right, so what are the degrees of freedom and how is it calculated? Now you can see the degrees of freedom. DF is 4. DF is 4, see right there, for Minitab, right between the chi-square and the p-value. Now how is it calculated? Well, it's calculated by row minus 1 times column minus 1. Okay, now what do I mean by that? Well, you had 1, 2, 3 rows. So 3 rows minus 1 times, and then you had 1, 2, 3 columns. Not happy, pretty happy, very happy. So 3 minus 1. 3 minus 1 last time I looked was 2. 2 times 2 makes 4. Not 5, 4. Oh my goodness, I pressed the wrong button. There we go. So that's how it's calculated. It's the row minus 1 times the column minus 1. They put it in here, right here. Row minus 1, column minus 1. That's your degrees of freedom. Okay. Now, looking at these outputs, what's the test statistic? You can see it. I circled it in green. It's 73.352. Right down here, 73.352. You never know which output you're going to be forced to look at, so make sure you can look at both of them. I could actually also make the TI calculator give you an output as well. The p-value, according to Minitab, is 0.000. According to the chi-square, the StatCrunch, it's just less than 0.001, which we've seen that before. It means it's really, really small, got a lot of zeros. These two programs just have a different way of writing that. Personally, I like the StatCrunch method better because the Minitab makes you feel like it is 0, but it's not. It's just really small. And there you go. You should draw a very skewed distribution. There we go. Degrees of freedom is 4. Looks like that. Very right skewed. 73 is way the heck out there. So you put 73 somewhere down here. That p-value is less than 0.0001. There you go. All right. So if the researchers set alpha to be 0.05, would the results be statistically significant? Oh, heck yes. Right. With a p-value that small, yep, you're going to be rejecting the null hypothesis. That's significant. Remember, significant means rejection of the null, right? Because the null is assumed to be true, so if you don't reject it, that's not significant to you. What's significant is if you've got enough evidence to reject it. And that would mean there is enough evidence to support the claim that income and happiness are not independent. Can't buy me love, notwithstanding, right? So, despite what the Beatles would have you believe, you kind of can buy love, right? So that, well, it's not really love, but happiness, right? So income and happiness are not independent, at least given that evidence. All right, now we move on to homogeneity proportions. So chi-square test for homogeneity proportions, we test whether different populations have the same proportion of individuals with some characteristic. You run the test the same way. So you literally pick the same things from StatCrunch and all that stuff. But the difference is that the test for independence and the test for homogeneity is how you set up your hypotheses. So the procedures for all the other steps are exactly the same. In the test for independence, what you say is that the null hypothesis is that they're independent, and then the alternative is that they're not independent, whatever the categories are. And then for homogeneity, it's that the proportions for the groups are all the same, and then at least one of those proportions is different. It's not quite the same thing. I'm not talking about independence here. I'm talking about the proportions. The proportions should all be equal. But other than that, you run it the same way. So it's just a question of how you set up your hypotheses, but everything else exactly the same. So for example here, in a study of the television viewing habits of children, a developmental psychologist selects a random sample of first graders. Each child is asked which of the following TV programs they like best: Lone Ranger, Sesame Street, or The Simpsons. Computer outputs for the test for homogeneity, and the results are given below. And I'm going to make us actually do this because I'm mean like that. So I'm going to note these problems here. This is 12.2 example 4. So this was examples, to be fair, 1 through 3 that we did before. And now I'm going to do example 4, 12.2, example 4. All right, so what I'm going to do is I want to kind of recreate that contingency table we've got going on there. So we have Lone Ranger, we have Sesame Street, and we have The Simpsons. Yes, you could make this in StatCrunch. I'm not particularly fond of StatCrunch's typing. That's one of the things that really frustrates me about StatCrunch. I like it a lot better for most other things than Excel, but the typing part is kind of a pain. All right, so boys and girls, and then remember this goes count, expected count, so you can see the count right there. It's 50, 30, 20. You don't even need the totals. Don't even bother. And then 50, 80, 70. So there we go. All right, now what I'm going to do is, because I don't want to run this test with Excel, because Excel doesn't run these tests, I'm not going to bother. I'm just going to kind of put some lines around that, kind of center it, make it look pretty. All right, and I'm going to copy and paste this stuff into Excel, or excuse me, into StatCrunch. Anywhere will be fine. I'll put it right here. Boys, girls, I got my Sesame Street, I got my Lone Ranger, I got all that good stuff. Right, you can kind of see it. This was gender. I better put that in. Gender. And I'll go back here and type that. Gender. Cool. All right, back to StatCrunch. All right, so we go stat, tables, contingency with summary. Scroll down. You want Lone Ranger, Sesame Street, and The Simpsons. Your row labels are in that gender column. So gender. Next. Expected count and chi-square. I mean, if you want to do any of these other ones, you can, but we don't need them. Expected count, chi-square, calculate. I'm just going to copy and paste that back into my lovely Excel spreadsheet. There we go. You can see the chi-square value. Well, we got a low p-value on this one too, so that's going to mean we're going to be rejecting. You can see it right down here. And if you're interested, you can see all your expected counts as well. There they are. So that's where all this stuff came from. You can see right there, that picture, that's exactly what we just made with StatCrunch. All right, now how many first graders were surveyed overall? Well, that's 300, right? That's the grand total. You can see it in the bottom right corner here. You can see it in the bottom right corner there, 300. Right? How many boys were there? Well, there were 100 boys in that group. And group 1, you can see, is 100. Group 2, you can see, is 200. Minitab, you'd have to try to figure out. I'd have to write somewhere which one was which. But StatCrunch, you can spot it real quick. Right? So I'd have to give you some information like group 1 was boys or something like that. All right, then find it, fill in the contingency table of observed values. Well, I just showed you how to do that. But basically, you kind of have to be able to dissect what you're seeing here. So there were 50 boys that liked the Lone Ranger, 30 boys that liked Sesame Street, 20 boys that liked The Simpsons, and so on. Then 50 girls that liked the Lone Ranger, 80 girls that liked Sesame Street, 70 girls that liked Simpsons. Okay, and then the totals, I just add them up. Okay. All right, now what about the expected values? Well, again, just be able to decipher what you're seeing. So expected values, the 33 and the 66, the 36 and the 73, and so on. And you can see them over here, 36, 73. So there you go, just type them in or write them in by hand. All right, so let's do the test. So the null hypothesis, this is what makes it different. So for an independent one, you'd say that gender and favorite TV shows are independent. That's what you'd write for an independence test. For a homogeneity test, what you say is, look, the proportion of boys who prefer Lone Ranger is the same as the proportion of girls who prefer Lone Ranger. The proportion of boys who like Sesame Street is the same as the proportion of girls who like Sesame Street. The proportion of boys who like The Simpsons, same as the girls, right? So you set it up for each group. You say these proportions are the same, these proportions are the same, these proportions are the same, these proportions are the same. And then the alternative is that at least one of those in the null hypothesis is false. At least one of those proportions groupings is not the same, right? So you could say it this way, you know, at least one proportion, at least one of those null hypothesis statements is false, or you could say at least one of these proportion pairings is not equal, or something like that, right? Is not true, or something to that effect. So you could write it a couple different ways. Alpha was 0.05. Not entirely certain why I did it that way, but alpha is 0.05. Oh, that's why. There we go. And then our chi-square statistic, is 19.318. You can see I blocked it in green right there, 19.318. And we already learned how to find it with StatCrunch. It's a beautiful thing. Then you make a chi-square distribution. This one's very skewed right. Degrees of freedom is 2, is really sharp, pointy, and then kind of comes down like this. It's not a pretty curve. And then the chi-square is over here, way over here at 19. P-value is less than 0.001. That means we would reject the null hypothesis, right? Which they didn't ask us whether that was significant, so I guess I can just say we would reject the null. That means there is enough evidence to support the claim that there's a significant difference between boys and girls proportions, TV shows or something like that, or favorite TV shows. All right. Other than that, we're pretty much good, right? It's very similar to the other stuff. It's just a question of how you interpret this null hypothesis. That's what's different. Again, the independent one will say TV show and gender are independent. That's what it'll say. And then that's independence. And then homogeneity will say, look, these proportions should be the same. These proportions should be the same. These proportions should be the same. That's your null. Right? You're assuming that there's no difference really between boys and girls or whatever. And then the alternative is that at least something in there is not the same. At least one of those proportion pairings is not equal. Not what it should be. At least one of those proportions is different from the others. I guess I could say that is different. That's what not equal means, but whatever. All right. We are done with chapter 12. I will see you back here for chapter 13. See you then. Oh, but don't forget, keep your Excel spreadsheet open, save it, and keep it, because we're going to use it again for chapter 13. So I'll see you back here for chapter 13, and we'll use that same Excel spreadsheet.